Hello everyone guys, welcome to ASM classes. Again we are doing statistics, and in statistics today we will discuss how to plot box plot. So before doing box plot we need to find Q1, Q2 and Q3. Yeah. So in order to draw box plot we need to find first Q1, Q2 and Q3. So why we are finding Q1, Q2, Q3? In order to plot the box. For example, I'm just taking an example. Let's say Q1 equals to 5, Q2 equals to maybe 10, and let's say Q3 equals to 20. Yeah. So in this case, let's say this is my y-axis. Yeah. And here I'm measuring, let's say, speed. Right. Now, in this case, let's say this is equals to 5, this is equals to 10, this is equals to 15, this is equals to 20. So this is my Q1, this is my Q2, and this is my Q3. So I need to draw a box. Yeah. So this is what we have drawn. Now, in box plot, we need to draw whiskers, right? The upper and the lower whisker. Now, how to draw or how to find the length of upper whisker? The length of upper whisker, how to find that? Now, in this case, the formula says that please apply this formula Q3 plus 1.5 IQR, right? So, in this case, let's say your Q3 is 20 plus 1.5 into 20 minus 5, which is 15, right? So, 20 plus 22.5, which is equals to 42.5. Now, let's say your data set is like this. So we have some values here. I'm just writing the few uppermost values. Let's say we have 40, we have 43, then we have 45. Now, in this case, this value lies within my data set, right? Therefore, we need to draw the whisker till 42.5. That means in this case, let's say this is 42.5. We need to draw the upper whisker till 42.5. But let's say my data set is still, just give me a second, 40. In this case, we need to draw the whisker till 40 and not till 42.5. So let's say this is 40. We need to draw the whisker till 40 because this value is lying outside of my data set, right? And we are making the graph to depict the data set. Since this value lies outside the data set, therefore we will not consider this value for the upper whisker, and hence we need to make our upper whisker till 40. Yeah. So I have told you 2 points. If your data set is like this, let's say 42 and 45, in this case, since 42.5 lies in the data set or in the range of the data set, we are making whisker till 42.5. But if the uppermost data is still 40, yeah, the uppermost observation of the data set is 40 and this value is 42.5, you need to make the upper whisker till 40. Yeah, this is all about upper whisker. Now, in this case, so let's take the first case. Let's say we have 42, we have 45, let's say we have 60 and 70, right? In this case, all the values lying above this value. So if I draw the number line, so let's say this is 42.5 All the values of the dataset which are lying above this value are known as outliers. Right? So in this case, we can distinguish outliers into normal outliers and extreme outliers. In order to find the normal and the difference between normal and extreme outliers, please write down the another formula, which is Q3 plus 3 IQR. That means 20 plus 3 into 15, which is equals to 20 plus 45, which is equals to 65. Now, any value that lies between these two values, are known as outlier. So if I mark here 65, in my data set 45 and 60. So here, somewhat here we have 45, somewhat here we have 60. These two values are my outliers and I will denote the outlier by a circle. Right? So how to denote 45 and 60 here? But let me first make it again. So let's say in this case, so this is not properly scaled. Let's say this is 42.5. So this is the upper whisker. Then we need to find 45. Let's say this is 45. We need to draw a circle. Then let's say this is 60. Again, we need to draw a circle. And all those values which are lying above this value, in this case, which is equals to 70, then in that case, 70 is known as extreme outlier. And we mark the extreme outlier with a cross sign. We mark the extreme outlier with the cross sign, right? Now coming to the calculations or the length of lower whisker. In order to find the length of the lower whisker, we need to write down the formula Q1 minus 1.5 IQR, which is equals to 5 minus, because my Q1 was 5, 1.5 into 15. Yeah, which is equals to 5 minus 22.5, and that is equals to 17.5 minus 17.5, right? So basically, in this case, again we need to see the data set. Now let's say my data set is like this. We have 2, then 4, then so on and so forth, right? In this case, since this value is lying below my data set, so the lowest value of my data set is 2, right? And this value is lying below my data set. So if my data set is starting from 2, this value is lying here, minus 17.5, which is not in my data range. Therefore, in this case, I need to make the whisker till only 2. So in this case, let's say this is 2. We are making the whisker till 2. Yeah. But let's say if I change the data set a little bit, let's say now my dataset values are like this: minus 30, minus 20, minus 5, and so on and so forth. In this case, minus 17.5 is lying within my data range, right? Therefore, I will make the whisker till minus 17.5. Please remember that. I will make the whisker till minus 17.5. So let's say this is minus 17.5. Yeah. Again, we need to find the outlier. The formula is any value which lies below of this value. Any value which lies below of this value. In this case, minus 20 and 30 are my outliers. But again, we can distinguish between outliers and extreme outliers. So please apply this formula Q1 minus 3 IQR, which is equals to 5 minus 3 is 3, and this should be 15, that is 5 minus 45, and that is equals to 40, minus 40. Let's say I am changing the data a little bit so that we will have a better understanding. Let's say in this case we have minus 50. So in this case, minus 20 and minus 30 are my outliers, whereas minus 50 is my extreme outlier. The reason being, so if this is the number line, this is minus 40, this is minus 17.5, and any value which lies between this range is known as outlier, and any value which lies below of this value, minus 40, are known as extreme outlier. Therefore, minus 50 is my extreme outlier, and minus 30 and minus 20 are my outliers. So basically, in this case, again, this is not properly scaled. This is minus 20, I will mark with circle. This is minus 30, I will mark with a circle. And let's say this is minus 50, I will mark with a cross sign. So this is how we are making the box plot. Now, the next is how to interpret the box plot. How to interpret the box plot, right? So in this case, basically, we are telling about the skewness. Right? We are telling about the skewness, whether the box plot shows a right skewed distribution or left skewed distribution or normally distributed. So first we will discuss about right skewed distribution. In the case of right skewed distribution, we can see that the length of the upper whisker is greater than the length of lower whisker. We can see that mean is greater than median. We can also see that Q3 minus Q2 is more than Q2 minus Q1. We can also see that. We have outliers towards the right side, right? And maybe there are no outliers towards the left side, right? So if this condition is satisfying, we are saying that this is right skewed. Again, so in this case, we need to see the diagram, and so I have written all these conditions. So if any one condition, so basically if this condition is satisfied, we can say that it is right skewed. If again this is satisfied, we can say that it is right skewed. Now, don't go for this interpretation. Sometimes you may find that this holds true, and in this case, Q3 minus Q2 is less than Q2 minus Q1. So this is a weak condition. So there might be, in one of the odd cases, there might be an contradiction. There might be a contradiction. So in these two conditions are satisfied, but the third condition says that this holds true. Don't worry, guys. In this case, also your diagram or your data set is right skewed. Yeah. So basically, in this case, my diagram will look like this. So this is the diagram of right skewed distribution. The length of the upper whisker is more than as compared to the length of the lower whisker. This is my Q1, this is my Q2, and this is my Q3. We know that Q3 minus Q2 is more than Q2 minus Q1. Then, in this case, let's say we have an outlier here. Again, there is an outlier towards the upper side and no outlier towards the lower side. Additionally, so if we calculate a mean, after this, I will do the box plot, how to plot a box plot in Excel. In Excel, they are showing a cross sign for the mean value. So let's say the cross sign is here and median is here. So we can say that mean is greater than median. In that case also, we are saying that my distribution is right skewed distribution. Now what about left skewed distribution? In the case of left skewed distribution, we can say that number one, the length of the upper whisker is less than the length of the lower whisker. Second, we can say that mean is lesser than median. Third, we can say that Q3 minus Q2 is less than Q2 minus Q1. And fourth, there might be some outliers towards the lower side. So some outliers towards the lower side, and there are no outliers towards the upper side, right? So basically in this case, my diagram will look like this. Yeah. So this is Q1, this is Q2, this is Q3, and I said that X is lying here, and this is an outlier. In this case, the length of the lower whisker is more as compared to the length of the upper whisker. This is mean value. My mean value is lesser. Remember that. If this is your y-axis, you are putting first smallest value and then higher values here. So the mean is lesser than the median. In this case, we can see that Q3 minus Q2, which is this distance, is lesser as compared to this distance, which is Q2 minus Q1, and there are some outliers towards the lower side. Now, in the case of normal distribution, basically, in this case, we are saying that number one, approximately the length of the upper whisker is more or less equals to the length of the lower whisker. Again, approximately mean equals to median. Approximately Q3 minus Q1 is equals to Q2 minus Q1, and there are no outliers. There are no outliers. So basically your diagram will look like this. So just give me a second. The diagram is looking like this. So in this case, the length of the upper whisker is approximately same as the length of the lower whisker. In this case, mean equals to median. In this case, Q3 minus Q2 is approximately same as Q2 minus Q1, and there are no outliers. Now, how can we do same thing with the help of Excel? Yeah. So let's say this is a data set, right? In order to plot the box plot, so go to insert. Just give me a second. Go to insert, then all charts. We can see box and whisker. Click here. Now this is the diagram. This is my Q1, this is my median, this is my Q3, this is my upper whisker, this is my lower whisker, and this we have a cross sign here. So in this case, basically, more or less we can say that the length of the whiskers are more or less approximately same, and in this case, the mean is somewhat greater than median, and Q3 minus Q1 is greater than Q2 minus Q1. Therefore, according to me, this is right skewed distribution, right? So if I change the data set, let's say now instead of 30, I'm making this as 90. Let's see what is a change. Now, in this case, if you see, guys, one more thing, in the case of Excel, they are treating outliers as outliers. They are not treating outliers as whether simple or extreme outliers. Therefore, they are marking a dot only. So in this case, we can see that since there is an outlier towards the upper side, and in this case, mean is rather median, Q3 minus Q1, uh, Q3 minus Q2 is more than as compared to Q2 minus Q1. Therefore, your distribution is right skewed distribution. Now, let us make this as 30, and let me change this value. Let's say this is minus 20 now. Now, in this case, the length of the lower whisker is more as per the length of the upper whisker. Therefore, in this case, my data shows this is a left skewed distribution. Yeah. So this is all about today's class. If you have any queries anytime, please do Write all the queries in the comment section. Keep smiling, keep laughing. I'll meet you in the next lesson.